This is a quick overview of the dual low-pass gate. It is a 2-channel vactrol-based low-pass gate. It builds on the legacy of classic low-pass gates of the past and present while improving circuit performance. With a completely unique CV circuit, it is able to tightly follow incoming CV and maintains great off-ness when CV is at 0 volts. I'm going to build a classic West Coast style patch by using Gilbert as a wavefolder. The first channel of the low-pass gate will be used to modulate the amount of wavefolding, while the second channel will be used as the final output for the entire voice. But first, I'm going to set up a simpler patch to show you what's going on. We have a CV and gate sequence coming from our MIDI to CV converter. Our CV sequence has already been patched to the VCO, while the gate sequence has already been patched to the envelope generator, which is opening up the low-pass gate. So when I patch the output of our oscillator to our low-pass gate, you'll hear the sequence. And as I dial back the dynamics knob, you'll hear the low-pass gate get shorter, darker, and pluckier. The dynamics control has a very wide range, which is great for creating dynamic patches, especially when you use the associated CV input to modulate the parameter. I'm going to undo this to build our more complicated patch. I'm going to take the sine wave output and patch it to a molt, and then we're going to take the first output of the molt and patch it to the input of our first low-pass gate. And the output of this low-pass gate is going to feed the input of Gilbert. The top section of mix 6 is going to be used to apply 5 volts to the CV input of the low-pass gate, which will hold the low-pass gate open. I'm now going to take Gilbert's fold output and apply it to the bottom section of mix 6. I'm going to take another output from the molt and apply it to the bottom section of mix 6. And then I'm going to take the output of this mixer and apply it to the input of our second low-pass gate. And we hear our folded sound, and we hear our sine wave. By mixing these two signals together, we can maintain a strong fundamental while having the complex timbre of the wavefolder. Gilbert can be easily modified to achieve deeper levels of wavefolding, which you hear when I engage the switch. You can also squeeze some extra gain out of the low-pass gate by using a stackable cable to join the dynamics input and the CV input. We can modulate the amount of wavefolding by taking an LFO and applying it to the same mixer that's feeding the CV input of our first low-pass gate. I'm also going to grab an output from one of the sample and holds from duophonic distribution to get some random voltage modulating the wavefolding as well. Now I'm going to dial back the dynamics, and then I'm going to take another LFO and apply it to the dynamics input. Keep in mind that the voltage at the dynamic CV input mixes with the knob position. You can hear how sometimes the low-pass gate rings out longer and how sometimes it gets shorter and pluckier. We're going to set up another patch to show what else the low-pass gate can do. The dual low-pass gate features high-quality, hand-matched film capacitors in the audio path. The two channels also use hand-matched vactrols along with CV circuits that are tuned to compensate for the vactrol's natural variations. Because of this, the dual low-pass gate is perfect for stereo and duophonic patches, or any other patch where you need two closely matched channels. I have recreated the polyphonic patch from the duophonic distribution video. As I modulate the dynamics control, you can hear the consistency between the two low-pass gate channels. I have already set up a mult so that I can route the same CV signal to both dynamic CV inputs. So when I grab this signal from Gilbert, you'll hear as the voltage rises, both low-pass gates will ring out longer. In a patch like this, Gilbert is great for processing CV and providing different modulation sources for different parameters. I've already taken the fold output and mixed it with the original CV sequence, and I'm going to use it to modulate the decay times of our two envelope generators. A lot of musical variation can be found by separately modulating the dynamics input and the envelope that's modulating the CV input.